Hi, my name is Bill Hanover, and today I'd like to talk to you just a little bit about overall equipment effectiveness, or OEE. What it is just a basic measurement of how available your equipment is, how it performs, and what kind of quality it produces. Okay, before we talk about OEE too much, we should understand that really what it's measuring is the losses that are affecting your equipment. So here are the 6 major losses that are common in equipment. Equipment failures, setup and adjustment time, idling and minor stoppages, reduced speed, defects in operation or process, startup, and reduced yield. Now, if you understand that these losses occur and we start measuring them, it's much easier to know where to put your attention when you're working on TPM efforts. Okay, so let's talk about machine availability for just a minute. Machine availability is the actual time left for production after you subtract all planned downtime. Alright, now planned downtime really comes in a few different forms. Breaks are planned, meetings are planned, TPM activities are planned, especially the internal type, because you actually have to shut down the machines to do them. Okay, there's also material shortages and maybe full Kanbans. Now, you may not think this is planned downtime, but really what it represents is a failure to plan or other constraints that are going on in your plant. This does not mean that your machine was not available, and that's a key differentiator here. Your machine was available to run, but it couldn't run because it didn't have the material it needed or the Kanban was full. Okay, what kills machine availability? Well, unplanned downtime. It's pretty basic, right? Okay, well that comes in the form of breakdowns, machine idle time, setup and adjustment time, and minor stops. You know, years ago I worked as a punch press operator, and one machine in particular I used to run, the thing would shut off on its own, I don't know, 20, 30 times a night. I'd have to go turn a certain switch, or turn a knob, flip a switch, hit a fault button, hit reset, and hit the go button again. Well, 20 or 30 times a night at maybe, I don't know, 20, 30 seconds, maybe even a minute every time, because I had to kind of travel back and forth there. Really, that became a problem. Okay, so the next part of the formula is performance rate. Performance rate is the measure of how well the machine was running when it was running. Okay, so performance rate is really a comparison between the ideal cycle time and the actual cycle time of the machine. So if your machine is supposed to put out one good part every 30 seconds, but it's putting out one every 60 seconds, obviously you have a real problem with how it's performing. On the other hand, if your machine's supposed to put one out every 30 seconds, but it puts one out every 15 seconds, that could be a real benefit, or that could cause you to start building way too much inventory, and that's another kind of problem, but we'll talk about that another time. Alright, so what kills performance rate? Well, longer than ideal cycle times. Okay, that's pretty basic. I sort of just explained that. But really, those long cycle times come from several different things. Poorly operating machinery, machines that have been slowed down. Sometimes it makes sense to slow down a machine, but a lot of times it does not. So that's something you have to look at with your individual equipment and what your customers are asking for. Okay, a lot of times it's poor and inefficient work processes. I can't tell you how often I find operators walking away from their machines to get materials, and that causes idle time for the machine. Okay, obviously if you can put the materials right where the operators are working, that's the best place. Alright, another thing is material variations. Back many years ago when I was a punch press operator, another problem we had was material would come in, it was all metal, and sometimes it was very thin and went in the dies just right, and I could punch holes like crazy. Other times it came in, the material was too thick, and we literally had to beat the metal onto the mandrel of the machine with a hammer, and then we had to use all of our might to pull it off the mandrel after the holes had been punched. Okay, so that was a big deal. Or sometimes it would come in with a really nasty weld seam on the inside of the tube, and it was so hard to get it on the mandrel, and it was really tough to get it off. Now, the difference between the two, sometimes I could make 50 parts an hour, and sometimes I could make 50 parts in an entire night. So that's a major difference. Really had a major effect on the performance rate. Okay, now let's talk about quality rate. This is the last part of our formula. Okay, quality rate tells us how many good parts versus how many defective parts a machine has produced during the time it was actually running. Okay, so if we produced 100 parts and 5 are defective, then we have a quality rate of 95%. Now, if you start thinking in terms of parts per million, then that's about 50,000 parts that are bad out of 1 million. Now, you might not be making a million, so let's just say you're only making 100 of a certain part. But 5 out of 100 really kind of takes away the profits and can create all kinds of other problems. And if you've been in manufacturing for very long, you know that occasionally some of those 5% that you made that were bad, some of them are going to wind up in the hands of your customers. That's why this becomes a real serious issue. And that's why we track it. All right. So what kills your quality? Well, improperly maintained equipment can cause all kinds of problems. Inconsistent materials, operator error, misaligned fixtures, incorrect settings, and too much guesswork. I've been in many plants where the operators are almost like artists. They have to tweak and adjust and do all kinds of special tricks, and they hold their tongue a certain way so that the machine finally works right. Okay, we really want hard settings. We want to get to the right place and stay there. We want a standardized process so that every time you set up a machine, it goes to the right, best place to begin. Now, I realize there are variations on that, but to the extent possible, that's where you want to begin, not with all the tweaking and adjusting that has to happen. Anyway, I could go on that for a long time, but I won't. But all these things and others contribute to the quality rate. Okay, so let's go back to our formula just for a second. It's availability, the time the machine is actually available to run, performance rate, how it ran when it was running, and quality rate, how many good parts it made while it was running. Okay, now there's a way to calculate OEE, and it's on paper, as you can see right here. I used to do it this way, but, frankly, it's too much work. I like to do things the easy way when possible. If you look at the bottom, though, you'll see an OEE percentage of 59.6%. In that same box, you'll see world-class performance, 85%. Now, that was the standard several years ago, and I suppose it's a good standard to get to if you're currently sitting at 59.6%. But really, what are you looking for? You're probably looking for in the high 90s as far as your OEE performance on every piece of equipment. And I realize that's difficult to get to, but it can be done, especially when you recognize the problems that are occurring, measure them, and then work your solutions out for each of those problems. Okay, let's do it the easy way. We're going to go to an Excel spreadsheet where you can plug in the information about availability, performance rate, and quality rate, and it will calculate your OEE for you. As you can see, this is just a basic Excel spreadsheet, but it is pretty handy on figuring out your OEE. So let's go up here to where it says date, and today's date is 12/16/2006. Okay, machine name, let's just call it, I don't know, press number 7. All right, very good. All right, for hours and shift, let's say we have people in the building for 9 hours. Ideal cycle time in seconds, let's say we have a 30-second cycle time for this machine running these particular parts. And by the way, on that, you can put the part numbers up here in this box if that's something that's helpful to you. Okay, break time in minutes. Let's say that everybody has 30 minutes worth of breaks plus another 60 minutes worth of lunch. Okay, TPM time, maybe they're taking 5 or 10 minutes every day to maintain the equipment. Let's just say, I don't know, 10 minutes. Meeting time, perhaps you have a little huddle every morning to get things started. How about another 5 minutes there? Other non-production time, this might be working on 5S or some other initiative that you have going in your area. So let's just say another 5 minutes happens in that area. Number of breakdowns, let's say there were 2. And total breakdown time, let's see, one of them was for 3 minutes and the other one was for 4, so let's just say there were 7 minutes of breakdown time. Okay, number of minor stops, the machine faulted out, let's say 6 times. And each one was about a minute, so we'll say 6 minutes. Okay, number of setups and adjustments, we only had 2 today, So we'll plug that in, and that time took, it was about 10 minutes each, so we'll give it about 20 minutes. Okay, total number of parts produced, let's say 450. Okay, number of rejects, let's say there were 5. As you can see, the data filled in below, it gives us an OEE, or an overall equipment effectiveness, of 51%, an availability rate of 92%. It's telling you that machine was available to run 92% of the shift. Okay, the performance rate is 57%, so when it was running, this is how well it was running. Obviously, it had some problems. Quality rate, well, that's around 99%. There's decimal places there too, but it gets you in the ballpark. So this is how this little tool works. I think you'll find it handy. Okay, now that you have this information, you can begin addressing where the issues are and hopefully increase that OEE to around 85% or better. All the best. I surely wish you great luck in your TPM efforts in getting your machines on schedule. Oh, and one last thing. If you'd like a copy of this little program, just click on the word here, and you'll be able to download it to your computer. There's no charge. I hope you find it useful. Take good care.